Another method in curve fitting is least squares. By far, this approach is the shortest. Check it out here in Numerical Solutions 2C problems. Least squares readily provide the functions in solving for the best fit line. However, there are again two approaches in the solution. But then, whatever approach one decides to use, you should still come up with the exact coefficients for A and B as if you used the other. The first approach is system of equations, and by the name, this uses two equations which should be solved simultaneously. The first consists of the summation of y, which is equated to a, with the summation of x, then add n times b. The second function is the summation of xy as equated to a times the summation of the square of x, plus b times the summation of x. The second approach is named ordinary least squares, and the best fit line literally uses the function y is equal to mx plus b. M, or the slope, is solved with the function n times the summation of xy less the product of the summations of x and y. All of this is divided by the binomial having n times the summation of x squared less the square of the summation of x. The y-intercept is simpler, which is the summation of y minus the slope m times the summation of x upon n. From the last function, the slope is used to determine the y-intercept, which means that you should plug in the exact value of m in order to avoid deviations for the value of b. From the four functions provided, note that n is required. But what is n? This is the number of data points in the set. Take the first example with 8 data points in the set. The x values have a regular interval of 5, but that doesn't matter in the solution using this method. First, we determine the best fit line for the dataset using system of equations. The first equation is the summation of y as equated to a times the summation of x plus nb. The summation of x and y are necessary to come up with the first equation. So from the dataset, the summation of x is computed as 220 and the summation of y is 246.74. Thus, the first equation is taken as 246.74 as equal to 220a plus 8b. The second equation for this approach is the summation of xy as equal to a times the summation of x squared plus b times the summation of x. There are two new parameters present in this equation, so create an extended table for xy and x squared. To take the summation of xy, solve for xy for each data point, being 52.5, 146.25, 303, 579.5, 939, 1475.95, 2124.8, and 3006.9. Their summation is 8627.9. Also solve for the summation of x squared, starting with 10 squared, which is 100, followed by 225, 400, 625, 900, 1225, 1600, and 2025, totaling to 7100. Thus, the second equation is 8627.9 as equal to 7100a plus 220b. With two equations already presented, plug the coefficients in your scientific calculator to have the function for the best fit line. However, we solve for the coefficients manually to show the solution. If we are to eliminate b, the first equation should be multiplied by 27.5, creating 6,785.35 as equal to 6,050a plus 220b. Subtract the second equation and get negative 1,842.55 for the constant on the left. 6,050 minus 7,100 gives negative 1,050a. So a is then solved as 36,851 over 21,000, or simply 1.7548. Knowing the value of a, have this plugged into the first equation and get 6,785.35 as equal to 6,050 times 36,851 upon 21,000 plus 220b, where after transposing, the equation becomes negative 402,281 over 105 as equal to 220b. So b comes to be negative 36,571 upon 2100, or that is negative 17.4148. Thus, the function for the best fit line of the dataset is y as equated to 1.7548x less 17.4148. How about working on the best fit line function using ordinary least squares? Using the slope-intercept formula, we are to start the solution for the slope m using the function n times the summation of xy less the product of the summations of x and y all over n times the summation of x squared minus the square of the summation of x. Since the values of the parameters are already identified, m is then 8 times 8,627.9 minus 220 times 246.74, all over 8 times 7,100 minus the square of 220. M is then simplified as 36,851 over 21,000, or 1.7548. B, on the other hand, is computed as the summation of y minus m times the summation of x all upon n. That is 246.74 minus m of 36,851 over 21,000 multiplied by 220 all over 8, giving b as negative 36,571 over 2100, which is simply negative 17.4148. Y is then equal to 1.7548x minus 17.4148, the exact function provided using the system of equations.